Welcome to this Wise Owl Excel VBA tutorial. In this part of our series on writing SQL for Excel files, we're going to look at how to add criteria to a query using the where clause. So we'll begin by looking at adding a where clause to a query and write some basic conditions using some standard conditional operators. We'll explain how you can compare one field to a constant value, to a value of another field, and also to an expression. We'll look at how you write criteria to do with numbers, text and dates, and when we're talking about text we'll have a little bit of a look at the like operator and some basic wildcard patterns, although we'll cover that in more detail in the next video in the series. We'll also look at how you can combine multiple criteria in the same where clause using both the and the or logical operators. We'll look at the in and the between special operators to give you a bit of an easier time writing more complex criteria, how to use the not operator to reverse the logic of your conditions, and to finish the video, a quick look at the is null operator to find blanks in your data. Quite a lot to do in this one, so let's get started. If you've been following along with this series so far, you'll be fairly familiar with the basic setup by now. But just in case you're jumping into the series in this video, let's give you a quick overview of how things work. We've got a basic macro-enabled workbook created, which allows us to run a query by clicking this button. And when we do that, it's going to extract information from a separate Excel file called Movies. The Movies workbook contains a variety of different worksheets and tables, containing lots of information about a range of different films. I'm going to keep the Movies workbook open for this video, just to make it easier for me to point out which bits we're talking to as we go through. But you're very welcome to close down the Movies workbook. All of the code will still work even if the Movies workbook is closed. I've saved both of these files in the same folder, and I'll drop a link in the video description so that you can download these and follow along and write the code along with me if you'd like to. A lot of the code I've written in the adding criteria to a query workbook relies heavily on Microsoft ActiveX data objects. Now, I'm not going to talk much about ActiveX data objects in this video. The focus here is on the SQL side of things. So just in case you are interested, we do have a separate playlist which explains how the ActiveX side of things works. So I'd recommend starting with this video here, how do I get data from a closed Excel file using VBA, if that's the part you're interested in. Just to talk briefly through the code that I've written so far, if we click the Run Query button, it triggers a subroutine called Create SQL Query. And all this does is essentially constructs the SQL string that we then pass into a separate procedure which deals with the ActiveX data object side of things. I've already set a reference to the Microsoft ActiveX Data Objects library, so if I head up to the Tools menu and choose References, you can see I've set a reference to the 6.1 version of the Microsoft ActiveX Data Objects library there. The subroutine itself, getQueryResults, does all the standard things. It checks that the Movies file exists in the expected location. It then makes sure that we've got a connection. It establishes the connection to the Movies workbook. It then opens up a record set, and the point at which our query gets used is this bit here. It sets the source property of the record set object. Everything below that is to do with writing out the information returned by the query into a new worksheet, sorting out all the formatting, and there's a bit of error handling code in there as well. So things shouldn't fall over too often in the video, but if they do, at least they'll fall over a little more gracefully than they ordinarily would. So just to demonstrate that this does actually work, if we head back to the menu worksheet, click the Run Query button, we ought to end up with a brand new worksheet selecting everything from the film sheet in the Movies workbook. I'm just going to head back to the menu sheet and tidy things up by clicking Delete All but Menu Sheet. Just before we start writing any code, let's have a quick chat about what we're about to do. I suspect a lot of this information will be familiar to many of you, but just to make sure we're as thorough as we can possibly be. In the series up to this point, we've covered the basics of the select statement. So we've looked at the select list to choose which columns we're returning in our queries. We've looked at the from clause to specify which range of cells from the source data we're using when we connect to an Excel workbook. And we've had a look at the order by clause to sort our query results. In this video, we're going to bring in the where clause, which allows us to write criteria to filter out the rows we're not interested in. Just to show you the basics of a where clause, the criteria we write are based on logical tests. So you may be familiar with those already in Excel VBA, but just to mention briefly how logical tests work in SQL. A basic logical test consists of value 1, an operator, and value 2. So you're comparing two things each time. The values that you specify can come from a range of different things. Your value could be a constant, so it could be, for instance, a basic number like the number 42, a bit of text like the words the matrix, or even a date. And we're going to cover all three different data types as we go through this video. Your value could also be a reference to a field, so it could be a reference to a data source which has column headers, like the title column header, or it could be just a reference to a simple field number if your data source doesn't contain column headers. Finally, your values can be expressions, so it could be a simple calculation such as this one here, which subtracts the value of the budget column from the value of the box office column. And we'll write some very basic expressions a little later on in this video. The operators, there's a fairly standard range of comparison operators that, again, I suspect a lot of you will be familiar with from Excel VBA, but just to make sure we're happy with the standard set of comparison operators, there's the basic range, equal to, not equal to, greater than, etc. So we're going to use all of those as we go through this video. Okay, now that we've got all the preamble out of the way, let's do something actually useful. I want to write a query which returns from the movies workbook and the film sheet all of the films which didn't win any Oscars, so everywhere where the value of the Oscar wins column is equal to 0. So that's a nice simple starting criteria to write. Let's head into the Visual Basic Editor, and we can modify our existing SQL query, select everything from the film worksheet, by adding the where clause to the end of that statement. The order of the keywords is important, as I showed you on the slide earlier on, select from where, and then we can reference our field name, so we can say Oscar wins, and then we can simply ask if that's equal to 0. The spaces here aren't necessary. I prefer the spaces just for readability purposes, but you can omit those spaces if you want to. At this point then, let's head back to the menu sheet, click the Run Query button, and there we go, we get all of the films with no Oscar wins. Okay, now let's try out a few of these other comparison operators. This time let's say we want to find all the films with at least one Oscar win. One way to do that in this particular example, because the Oscar wins column contains only whole numbers, is to ask for any value that's greater than 0. If we've only got whole numbers in the column, the first value that's greater than 0 must be 1, so that will return all the films with at least one Oscar win. Let's head back to the Visual Basic Editor, and we can simply change our equals operator to the greater than operator. Once we've done that, we can head back to the menu sheet, click the Run Query button again, and this time we'll return all the films with at least one Oscar win. I forgot to mention briefly earlier on that if you wanted to see how many results you're returning, as well as checking the number of rows in the worksheet, of course, I've added a bit of code that will write out the number of results returned into the immediate window. Now, if it were possible that the Oscar wins column did contain decimal numbers and we wanted to make sure we found only those films with at least one whole Oscar win, then we could change our criteria to say greater than or equal to, and then enter the value of 1. If we then head back to the menu sheet and we run that query again, we'll see the exact same number of results, because that column does indeed contain only whole numbers, but just to demonstrate the principle of the difference between greater than and greater than or equal to. In principle, in this particular set of data, because you can't win a negative number of Oscar wins, and providing there is sensible data entered into that column, nobody's mistakenly added a negative number, we could also check for any value or any row where the value of the Oscar wins field is not equal to 0. If it's not equal to 0, then it must be a whole number that is greater than that. So we can change the greater than or equal to symbol to not equal to, and then change the value, the constant, to the number 0, head back to the menu sheet, and then run the query again. So once again, in this case, we return all the films with a non-zero number of Oscar wins, which in this case returns the exact same number of results as the previous two queries we've written. For less thans, let's just modify our column name. Let's say rather than referring to the Oscar wins column, we're going to say run time instead. I want to find all the films with a run time of less than 80 minutes. So some of the shorter films on our list. So let's change our criteria to say less than 80. And then if we head back to the menu sheet and we run that query, we'll see all the films whose runtime is indeed less than 80 minutes. If we wanted to include 80 minutes in our criteria, then again you can modify the operator to say rather than less than, we can say less than or equal to. So we got 11 rows when it was less than 80. If we switch back up to the menu sheet and run that query again, this time we've included an extra film, the one King Solomon's Mines there, with a runtime of exactly 80 minutes, and that's reflected in the results in the immediate window there as well. Finally, just on the subject of basic operators, just in case you have experience with writing SQL in a different dialect, such as Transact SQL in Microsoft SQL Server, you may be familiar with using the exclamation mark to represent not. So let's just change our criteria back to looking at the Oscar wins column. Earlier on we said something like not equal to 0. In Transact SQL you might be familiar with writing it as an exclamation mark equals, so not equal to. But sadly that doesn't work in this particular provider that we're using to connect to an Excel file. So if you do try to use that style of operator when you try to run the query, that will fail. As you'll see, we get a missing operator, so it doesn't recognize the exclamation mark for basic comparison operators. So at this point I'm just going to click OK, and then I'm going to delete everything but the menu sheet just to tidy up, and then we'll move on to something slightly different. So writing conditions or logical tests in your where clause is fairly straightforward when you have some nice column headers to reference like this one here. But what if you're connecting to a worksheet or a range of cells which doesn't have any column headers, such as, for example, the Film No Headers worksheet in the Movies workbook? Let's just try to do that. Let's try to return all of the Oscar-winning films from the Film No Headers sheet. If I switch back to the Visual Basic Editor, I've got a few changes to make. So let's first of all change the table we're referencing here to say Film No Headers rather than just film. And I want to change my operator from not equal to, the one that we know doesn't work, to just say greater than. I also need to change one extra property for my connection string. So I want to indicate to the connection that the table I'm connecting to doesn't contain any column headers. So scrolling down into the main subroutine, we've got a connection string setting, and in the extended properties section, we can set the HDR property to say no. Having done that, of course, this won't work if we try to reference the Oscar wins field. That doesn't exist in the table we've referenced. But just to demonstrate that, if I switch back to the menu sheet and run my query, that will fail, saying that it doesn't recognize a parameter name. We'll talk more about parameters in a later video in this series, but it's basically not recognizing the value Oscar wins as a reference to a field. So in order to refer to the field in the column in the table with no headers, we need to know which field number it is. So there are 14 columns in this particular worksheet, and the Oscar wins column is the 14th of them all. So one way to reference that column, the only way to reference that column if it doesn't contain column headers, is to change the column name to the generic F for field, and then the number of that field in that range of data, so F14. Having done that, if I switch back to the menu sheet and I click the Run Query button again, this time I get all of the Oscar-winning films without having to use the column names. I've just used the basic field number instead. Now, clearly things are much easier when you do have column headers to reference, so for the rest of the video, let's switch back to referring to the film sheet. So let's just change the select statement to say select everything from film, and then I can head down into my connection string property and set the header extended property back to yes. And then having access to our column names again, let's make a change to our criteria. So far, all of our logical tests have used a reference to a field followed by a constant value, in this case up to this point just a number like the value 80 or 0 or 1. You might sometimes want to compare the value of one column with the value of another column. So for this example, switching back to the Movies workbook for the time being, we've got a budget column and a box office column. Now, if the box office column's value is greater than the budget, that means that the film must have made a profit. So I'd like to see all of the profitable films by comparing the box office with the budget. So heading back to the Visual Basic Editor, I can change my field reference there from F14, I can say box office, and then check if that is greater than, not the number 0, but a reference to a different field. Okay, so having done that, we can switch back to the menu sheet and we can click the Run Query button again, and this time we're seeing a list of all of the profitable films. We could use the same technique to check for possible data entry errors. If we have a look at the nominations and Oscar wins columns, it shouldn't be possible for a film to win more Oscars than those it was nominated for. But let's just check to make sure that's true. If we switch back into the Visual Basic Editor, this time I'm going to ask where the Oscar wins is greater than the nominations. Now, it shouldn't be possible for that to return any results, but let's just make absolutely certain that that's the case. If we switch back to the menu sheet, and if you've watched previous videos in this series, you may be able to predict what's about to happen. So there is one film in the list which has a value in the Oscar wins column which exceeds its nominations. That was originally, in a very old version of this movie's database, that was originally a typo, but it was a useful teaching point, so we've deliberately left that mistake in there for later versions of the movie's database. So far we've dealt with comparing a field reference with a constant and a field reference with another field reference. The one type of value we haven't dealt with yet is an expression or a calculation. Let's just have a very quick look at why that might be useful. Let's say from my film sheet, I want to find all of the films whose profit was at least $1 billion, not box office, overall profit. So to work that out, I'd have to subtract budget from box office to work out the difference, and then test if the result of that expression or calculation was at least 1 billion. So in order to do that, let's head back into the Visual Basic Editor, and I'm just going to change my criteria entirely. Let's get rid of the entire criteria so far. So after the where clause, I want to first of all write my basic calculation or my basic expression. Now, I'm not going to go into a huge amount of detail here, simply because we're going to have an entirely separate video, perhaps actually several different videos on the topic of expressions. It's a fairly large topic. So just the absolute basics with some simple arithmetic. I'm going to take the value of the box office column, and then I'm going to subtract from that the value of the budget column. I can then check if the result of that expression is greater than or equal to 1 followed by 9 zeros. So I just have to count those out as I type them, otherwise I'll get the wrong number. So it's a result of that calculation at least 1 billion. I can happily here go back to the menu sheet and I can run that query and it will work quite happily. There's all the obscenely profitable films. I don't think I would have predicted Minions would be one of those, but there we go. So there we are. I haven't noticed it displayed the result of that calculation anywhere. Again, we'll cover how to do that in a later video in the series. Now, your calculations and your expressions can become quite complex, of course. One thing that can help when you're writing complex calculations is not really necessary here, but you can use round brackets or parentheses to group together the bits of your expressions you want to be evaluated together. So just wrapping up this basic calculation in some round brackets just makes it a little easier to read. You can see that that part is going to be evaluated first. Just like in VBA and in Excel in general, expressions are evaluated from the inside outwards. So anything inside some round brackets is evaluated first before then comparing the result of that expression with the value, the constant we've added here. The end results here are no different. This is purely for readability purposes with such a simple example, but just to introduce the concept of using parentheses or round brackets to group together specific bits of an expression. Just as one other example of this type of technique, and to demonstrate that we can use different arithmetic operators, let's find a list of all of the films that cost more than $2 million per minute to make. So to make that work, we'd have to work out the cost per minute for each film. And we can do that by dividing the budget by the runtime in minutes. So I can modify this expression here. So inside the round brackets, I can take the budget field and divide that by the runtime field. So that will work out the cost per minute of each film. and then I want to check if that is greater than or equal to 2 million. So I'm just making sure I've got the correct number of zeros there. It's tricky to see. We don't want to type in commas here, of course. Commas are a formatting thing. Although it's much easier to read, that would cause problems when we try to run the query. So let's make sure we don't put the commas in there. So having done that, if I were to head back to the menu sheet and run the query again, we'll see we get all of the films which cost at least $2 million per minute. What an obscene amount of money. I'm not sure that was money well spent for some of those. Let's move on and look at the different types of constants we can use in our criteria. So far, the only type of constant we've used has been a simple number. And when you want to write numbers into your SQL queries, you simply write that number directly in with no additional characters wrapped around it. For the next example, I'd like to return a list of films based on the genre field. And the first film in my list is in the adventure genre, so let's try to return all the films with that same genre, adventure. To make that work, let's head back to the Visual Basic Editor, and I'm going to change my where clause entirely. Let's just remove the entire thing, and we'll refer to the genre field, and then ask if that is equal to. And I'm going to try to type in just the word adventure. This isn't going to work, by the way, but just to demonstrate that, if I were to head back to my menu sheet, and let me just quickly tidy up as well by deleting all but the menu sheet, if I click Run Query, that fails because it doesn't recognise the word adventure as a word, as a string literal. Clicking OK, let's head back to the Visual Basic Editor. What our query thinks adventure is a reference to a column or a field in our data source called adventure. I've been making a point of wrapping square brackets around the names of my identifiers, so the names of columns, the names of tables, etc. As I mentioned in previous videos, it's not always necessary to use square brackets around identifiers. You only tend to need to do that if your identifier contains a space or another unusual punctuation character. So here in this case, the film table definitely requires the square brackets because of the $sign, whereas the genre column name doesn't require square brackets because it's one single word with no spaces or punctuation. So basically this is the way SQL reads this query is it's trying to compare a column or a field called genre with a field called adventure, and that's not what we're trying to do, of course. So enough waffling, onto the solution. To make this be treated as a piece of text, we need to wrap some delimiter characters around the word. And the delimiter characters for strings, you've actually got two choices here with the provider that we're using to connect to an Excel workbook. One option would be to use the same string delimiters as we use in VBA, the double quote characters. But that causes a problem. If I try to wrap the word adventure in its own set of double quote characters, when I move away from that line, the problem is caused by the fact that you can't simply insert a single quote, double quote character inside another set of double quote characters. In order to make this work, you'd have to put double quotes, and those will be translated into and treated as single double quotes, enclosing the word adventure. It's all a little bit confusing, but just to prove that this does actually work, heading back to the menu sheet, clicking Run Query, I do indeed return all of the adventure films. But that's a little bit rubbish. I don't particularly like that. You can see when we've printed out the select statement, it does translate those double quotes into single double quotes, so the final query reads a little bit more naturally when you look at the results here. But when you're looking at the code you've written, it's a little bit tricky. So what I prefer to do is, instead of using the double quote characters, use single quotes or apostrophes instead. So the same end results, if I head back to the menu sheet, click the Run Query button, I get all the adventure films again, but I think the query itself is a little more readable in our code. One other thing to note about text is that the provider that we use to connect to an Excel workbook doesn't treat string comparisons or text comparisons as case sensitive. So that means I could spell the word adventure in any combination of upper and lowercase characters, and I know it looks completely unnatural and strange to do so, but just to demonstrate, if I switch back to the menu sheet, spelling adventure like that still returns all of the adventure films, even though the case doesn't match. Now, For the moment, we're just going to accept that string comparisons aren't case sensitive for this video. In the next video in the series, we're going to look at a whole bunch of extra things we can do with string comparisons, including how to make them case sensitive. But for now, for the rest of this video, we'll just accept that it's not. We can also use other comparison operators with text columns. Let's change our criteria to say where title equals. Then I'm going to look for the film King Kong. I'm using King Kong because I know there are several different versions of King Kong in my database. So if I head back to my menu sheet and I run this query again, I'll get the 3 different versions of King Kong that have been released. What if we wanted to find all the films apart from the King Kong films? If we head back to the Visual Basic Editor, in the same way we can ask for something that is not equal to a number, we can ask where text is not equal to a specific string of text. So if I head back to the menu sheet and run that query again, that's going to return all of the films except for the 3 King Kong films. There are 1,200 films in the entire database, so here you can see in the output I've eliminated 3 of them. It's also possible to use greater than and less than operators with text, which might seem a little bit strange until you consider the fact that you can sort text in ascending and descending order. So, if you wanted to find, let's say, alphabetically all of the films which appeared after the letter X, if you were to sort it alphabetically, let's say we could change the operator to say greater than or equal to, and then I'm going to write the letter X as my string. So if there was a film called X, that would be returned, along with all of the films after X if you were to sort them alphabetically. So heading back to the menu sheet and clicking the Run Query button again, I get all of the films from the letter X. They're not sorted alphabetically here, of course, they're just returned in the order that they appear in the original film sheet. Of course, it's nice and simple to sort your query results afterwards, just by adding an order by clause to the query. So in fact, just to demonstrate this, let's add an order by clause to the end of our select statement, and I'll say order by title. It will be in ascending order anyway, but let me just indicate that as well by saying ASC. And then if we run the query again, we'll find the results sorted alphabetically, so it's a little easier to see. It's returning what we expect. Less than works equally well as well, so heading back to the Visual Basic Editor, let's say this time we want to find all of the films whose title begins with either a number or A or B. So we could find all the films whose title is less than the letter C, and if we were to head back to the menu sheet and run the query again, that returns all of the films which, were you to sort them all alphabetically, or alphanumerically I should say, it will return all of the results up to but not including a film whose title would be just the letter C. Now, perhaps one of the most useful and interesting things you can do with text columns isn't to compare them with a specific letter or a specific word, but it's to compare them with a pattern of text. And in order to do that, we need to look at a different operator referred to as the like operator. So the like operator essentially replaces your standard comparison operator, like an equals or a greater than, and it allows you to match a pattern of text with your text column. So let's have a look at how we can make that work. I'm just going to change my criteria back to looking for films that are equal to the title King Kong. So we already know that what this is going to return. We've already seen these results, but just to reassure ourselves, let's run that query again. So we get the three versions of King Kong that exist in this database. Let's head back to the Visual Basic Editor, and what we're going to do now is change the equals operator into the like operator. Now, it's perfectly acceptable to write your text criteria like this, use the like operator instead of equals. It doesn't actually affect the results at this point. Heading back to the menu sheet, I'll go to the correct workbook as well. If I run my query, I still return those same 3 King Kong films. The power in the like operator comes with the inclusion of wildcard characters. So, back in the Visual Basic Editor, let's say I want to find all of the films whose name begins with the phrase King Kong, followed by any number of any characters at all. To do this, after the phrase King Kong, still inside the single quotes, I can type in a percentage symbol, which is the wildcard character which represents any number of any characters, including no characters at all. So I'm still going to return the same 3 King Kong films, plus any additional films that begin with King Kong. It's probably easiest to see this by example if we switch back to the menu sheet, click the Run Query button, we get one additional film, which is King Kong vs Godzilla. Now there are lots of very interesting and useful things we can do when we combine the like operator with wildcard characters, and we're going to go into those in a lot of detail in the next video. But just to give you a few of the basic ideas in this video, let's just try changing our query string to say like king followed by the percentage symbol. So this is going to return a few more films. There are more films which begin with the 4-letter sequence K-I-N-G than with King Kong, as you might imagine. So let's head back to the menu sheet and run that query again, and we get all the films whose first 4 characters are the letters K-I-N-G. Notice that includes words where the word king is part of the word, like kingdom, etc. Let's say we wanted to find all the films that end in that 4-letter sequence K-I-N-G. Back into the Visual Basic editor, we can move our wildcard character from the end of the string to the beginning. So the film title would begin with any sequence of characters, and the final 4 characters would be K-I-N-G. Heading back to the menu sheet, we can run that query quickly to see the set of results. So again, that includes words in which the 4 letters K-I-N-G are part of the word. And of course, you can probably guess or imagine, or you perhaps already know, that you can include multiple wildcard characters in the same string. So I could wrap a set of wildcard characters around the 4-letter sequence K-I-N-G. So wherever that sequence appears in the film title, that result will be returned. So heading back to the menu sheet, clicking the Run Query button, there we go, there's our list of films. Unfortunately, I'm sorry about this, it does indeed return a couple of Twilight movies. I can't help that. We've got the 4-letter sequence K-I-N-G in there. But you can hopefully see, just using those few basic examples, how useful the like operator and wildcard characters can be. Just one final note in this video about the like operator and wildcard characters. What if we wanted to reverse the question we're currently asking? So at the moment I'm asking to show all the films whose name contains the 4-letter sequence K-I-N-G. What if I wanted to exclude those films from the list instead? Now of course, if we're using the equals operator, which wouldn't work correctly here, it wouldn't interpret the wildcard characters correctly, but if I have equals I can change that to say not equal to, using those symbols, but I can't do that in quite so simple a way with a like operator. Let's just say, instead of eliminating the king films, let's get rid of something we actually want to get rid of. So I'm going to change the word king to the word Twilight. And if I run that query with the word like, just so that we can see we do indeed return a bunch of Twilight films, apologies. Unfortunately, it includes one film that isn't quite so terrible, The Twilight Samurai, which will be a sacrifice, but there's a small sacrifice to make, I think, to get rid of the other Twilight movies. So there are 6 rows there containing the word Twilight. To eliminate those, I could add the word not before the word like. So that simply reverses the logic of the question we're asking. And if I head back to the menu sheet and click the Run Query button again, I return all of the films except for the 6 films containing the word Twilight. Okay, so we've dealt with numbers and we've dealt with at least the basics of text. Let's move on to the final data type we need to consider, dates. I'm just going to change my query. I'm going to take away the order by clause this time, and I'll change my where clause to refer to the release date field. Now I'm going to ask to show a list of films released on a specific date, the 20th of October 2006, and the only reason I've picked that date is because I know in my database there are multiple films which share that release date, so I want to see multiple results returned. The question is, how do we find films, or how do we enter our date value so that it's interpreted correctly by the query? So I want to ask where the release date column is equal to something. Now as you'll know, there are a variety of different ways of writing dates formats in VBA. The problem is, what characters do I need to enclose my dates? If I try to do this, let's say I did 20/, 10/2006. And I appreciate that if you're in the States, that looks completely unnatural. It should be 10/20, but bear with me just for the moment. The problem is that that value isn't treated as a date at all. This value is treated as an expression, 20 divided by 10 divided by 2006, which isn't quite what we want here, of course. If I tried to run that query from the menu sheet, in fact, let me just tidy up a bit as well. If I hit the Run Query button, that says it returned no results, because apparently there are no films whose release date is equal to the result of that expression. I don't even know what the result of that expression would be. I'm not going to try to do it, do the mental arithmetic. The important thing is we know that that doesn't work. For the provider that we're using to connect to an Excel workbook, the ACE OLADB provider, the delimiter symbol for dates is a hash symbol, or I believe a pound symbol, as you may know it. So wrap the set of hash symbols around the date. Now I appreciate that this is still unnatural for some of you watching this video. It's the day first, followed by the month. But again, just bear with it. If I head back to the menu sheet and run my query, I do indeed return all the films released on the 20th of October 2006. This particular format here, by the way, in the final output, I've added on afterwards. So that was just to try to make it a little more readable to guarantee we know exactly what type of date we're talking about. Now, I put 20th of the 10th, and a few of you are thinking, that's horrible. I'm going to switch that to the 10th of the 20th, or October 20th by saying 10/20, 2006. And curiously, although you wouldn't expect this in some other SQL systems, if I run my query again, I get exactly the same list of results we saw previously. It's those same 3 films with the same release date. And the reason we're able to do that is because, of course, the number 20 is completely unambiguous. It can only possibly be the number of the day of the month. It couldn't represent the month of the year. So let's say we wanted to do something that's a little more ambiguous. I want to find all the films now that were released on the 1st of October 2004. And again, I'm doing this simply because I know there are multiple films released on that date. So 1st of October 2004, I'm going to try to do this, first of all, the UK way, the way I naturally want to do things. So 01/10/2004. Now I know there are 3 films in my database with that release date. However, if I switch back to my menu sheet and I run my query, that returns no results. And the reason for that is that when the day of the month and the month of the year are ambiguous, the date is read in month, day, year style. So in order to return the results I want, I must do things the way our colonial cousins want to do things, with the month first and the day second. If I head back to the menu sheet now and run the query, it does indeed return the 3 films released on the 1st of October 2004. Now, while I'm sure that our American friends will be delighted to learn that by default dates are treated in month, day, year format, for we poor unfortunates in the UK and other places, this is some potentially very misleading code. I'm reading this thinking that I'm about to return all the films with a release date of the 10th of January 2004, but as we know, that's not what's happening. So what options have we got to make this a little less confusing? Well, fortunately, the provider that we use to connect to another Excel workbook using ActiveX data objects supports quite a wide variety of different date formats. So just to give you a few basic ideas for things that you could try to do, let's change this date so it says 01 followed by a space, followed by the word oct. Now it's impossible in a date for the word oct to be misinterpreted as the number of the day of the month. So if I head back to my menu sheet and run my query again, I see I get a list of all the films released on the 1st of October 2004. Back to the VB editor again. If I wanted to write the full word October, I could do it that way as well. That will happily work. So back into the menu sheet and run the query again. There we go, the same list of films. Back to the Visual Basic Editor. If I wanted to put some kind of separator character between the day and the month and the year, that will work quite happily as well. So we've got quite a wide variety of choices here. You can even put the month name in front of the number of the day of the month if you want to do it in that very strange and unusual way. Let's go October 1, 2004. So I'm not even going to bother with the 0 in front of that, but that will still work as well. So what's the best date format to use? Well, I guess the best date format to use is the one that you like the best, I suppose. It's a little bit like the question of where you place your commas when you're writing a list of column names in the select list. Do you put them at the beginning of the line or the end of the line? Who cares? Do what makes you happy as long as it works. There is, however, perhaps a small piece of advice I could give you about date formats. This is going to be particularly pertinent if you work in other dialects of SQL, such as Transact SQL in SQL Server. The preferred date format for writing date constants conforms to an international standard format for dates. I'm sure you guys are all well up on your ISO numbers, and I'm teaching you how to suck eggs here with ISO 8601, but this is the standard defined by the International Organization for Standardization for how dates should be written in information interchange systems. And if you wanted to do it and conform to this particular style, then the correct way to do it is to put the year, followed by a dash, then the double-digit month, then another dash, and then the double-digit day. So just to demonstrate that that works, I'm going to change my date so it's 2004-10-01. Having done that, if I head back to my menu sheet one more time and run the query, I return exactly the same list of results. So it's, I suppose, a reasonably nice compromise. The idea behind this system is that you work from the more general or wider, longer period of time gradually towards the more specific, smaller unit of time. So year, month, day, hour, minute, second, etc. It's a bit of a compromise, I agree. I guess the definition of a compromise is a situation in which nobody is entirely happy. So perhaps I'll enforce my mild misery on everyone else from this point on in the video and always write my dates in that specific format. As you might expect by now, we can use the same standard comparison operators with our dates as we used with our numbers and text. So for the next example, let's say we want to return all the films released since the 1st of January 2016. The reason I'm going for a date so far in the past is that my database is so hopelessly out of date that the most recent film in the database was added in 2016. So let's change our operator to say greater than or equal to, and then we can change the year to say 2016, and the month to say 01 for January, and the day will be 01 as well. So I would also like to see my films sorted in ascending order of release date, so while we're here let's add an order by clause and say order by release date, and then let's say ASC. So having done that, back to the menu sheet, click the run query button again, and we get all the films released since the 1st of January 2016. Of course, were there films in the database released later than 2016, they would also be included in the results. The reason it's cutting off at December 2016 is because that was the last film or the most recent film that exists in that table. One thing that you do need to be slightly careful of when talking about date values is if your dates include a time component as well. Now, none of our films' release dates include a time component, but just to demonstrate what I mean by being careful, I want to change the way my query works. I want to find all the films released since or prior to, but including 1993, June 11th. So that's the release date for Jurassic Park. It just happens to be the first film in my list. So if I head back to my Visual Basic Editor, and I'm going to change my query to say less than or equal to 1993-06-11. And I want to order by descending order this time so that the Jurassic Park should appear at the top of the list. It should do anyway if we just had no sort order at all, as it's the first film in the list. But let's just guarantee that it appears at the top by sorting in descending order of release date. So this will be inclusive of 11th of June 1993. Heading back to the menu sheet, if I click the Run Query button, Jurassic Park does indeed appear at the top of the list. Now let's see what happens if we head back to the Movies sheet. Let's imagine, for example, that Jurassic Park had been released at 11 AM on that particular date. I'm just going to select that cell and edit the contents to say 11:00:00:00. So 11 AM on that specific date. Now the field is formatted not to include the date or the time value, but you can see that clearly there. If I select the cell, the time is included. So if I head back to my menu sheet and I run my query again, you can hopefully see that Jurassic Park hasn't now been included. When you write a date value and you only include the year, the month and the day, it assumes you mean basically midnight on that day. So the very first point in time on that specific date. It's the equivalent of writing your date like so. So the year dash month dash day, followed by 00 for the hour, colon 00 for the minute, colon 00 for the second. Just a quick hint for people, again, coming from a different SQL background in SQL Server, for example, in Transact SQL, you could then also include the 10th, 100th and 1000th of a second if you're using things like date time. The provider we use to connect to an Excel workbook doesn't store any units of time lower than a second, so you wouldn't include that in this example. So again, just to prove that this does run, I haven't changed the way the results are returned yet. This is still returning everything from the very first point in time on that specific date. But if I head back to my menu sheet, this won't return Jurassic Park. But if I headed back to the Visual Basic Editor, if I wanted to include everything prior to and including a specific time of day on that date, then I could include the time as 11 o'clock or 11 AM. So having done that, if I were to go back to the menu sheet and I can run that query again, that returns Jurassic Park now again. So again, it's formatted in a particular way so it doesn't show the time, but you can see there that the time has been included. A slightly easier way to do that, if it wasn't the time of day you particularly cared about, you just wanted anything that happened from the 11th of June 1993 and earlier, then by far and away the simplest thing to do is not include the time. That takes quite a lot of extra typing. It's simply to say less than the next day. So go for the 12th of June 1993, and the first bit of time you will return, the first point in time that is earlier than or before the 12th of June 1993 is the 11th of June 1993 at basically 23:59:59. So that would be the equivalent. But as I say, much easier just to say before the next day. And if I head back to the menu sheet and run that query again, I do indeed again return Jurassic Park. Just to return everything back to normal, I'm going to head back to my movies workbook and I'm going to take away the time of day that I added. We're going to talk about dates and times in a lot more detail in another video later on in the series, but I thought that was worthwhile just briefly mentioning in case you are working with date and time values. So I'll just tidy up my workbook a little bit now. I'll take away the everything but the menu sheet, and then we can move on to look at how we can combine multiple criteria in the same where clause. So let's move on and look at how we can combine multiple logical tests in the same where clause. To do that, we need to know the basic pattern we need to follow to combine logical tests. So a quick look again at the absolute basics. It's similar to the pattern we use for a single condition. You have a logical test on one side, followed by a logical operator, followed by another complete logical test on the other side of the operator. So what logical operators can we use? Well, there are several we can use, but the main two we're going to encounter in this video, and the main two you're likely to encounter in general, are the AND operator, which you may well be familiar with from VBA already. The AND operator returns true when both of the logical tests on either side of the operator return true. The other standard operator is the OR operator, and the OR operator returns true when either condition returns true. So let's have a look at how we could combine conditions using the AND operator first of all. For the first example, I'd like to find all of the films in my database that were nominated for but did not win any Oscars. So I need to combine two conditions. The nominations must be greater than 0, but the wins must be equal to 0. So back into the Visual Basic Editor, let's change our where clause entirely. In fact, because we're going to be adding multiple conditions. This line of code is going to become quite long. So let's take the opportunity to break this up into a few different lines instead. I'm just going to type in a space and an underscore just after the equals operator at the beginning of the SQL query line, and then on the next line, indent that code one space. I'm going to follow the convention of breaking each separate clause in the select statement onto a separate line. So just before the from clause, I'm going to type in some closed double quotes and then concatenate that with a continuation character, space underscore, and then open up a new set of double quotes on the next line. Then after I've referred to my table, just before my where clause begins, I'm going to close some more double quotes, ampersand space underscore, and then the where clause will sit by itself on a separate line, and then just before the order by clause, once again close some double quotes, concatenate that with a new line character, and then open up some more double quotes on the next line. So that just helps us to focus on the where clause. We can alter the where clause without risk of messing up the rest of our query. So our two conditions then at that point, I want to find all the films with an Oscar nominations value of greater than 0 and a wins value of equal to 0. So let's get rid of our existing condition. So where, and then I can refer to the nominations field and ask if that is greater than 0. And then combine that using the AND operator and ask to check where the Oscar wins is equal to 0. I'm deliberately leaving a space at the end of this line, by the way, because that's going to be concatenated with the word order by. So when the entire string goes together again, I don't want the 0 to be part of the word order by. I want to make sure there is definitely a space there before the order by keyword begins. We'll see the final result in the immediate window, so let's just maybe modify the order by clause as well. Let's say order by nominations in descending order, so we can see the film that had the most potential but had the biggest failure, I suppose. Let's head back to the menu sheet, click the run query button again, and there we go. So the colour purple was nominated for 11 Oscars and didn't win a single one. So if we head back to the Visual Basic editor, you can hopefully see the structure of the entire query in the immediate window at the bottom. So when you read that all as one single continuous string, we've got the space there between the 0 and the keyword order by. When you have multiple conditions in the same where clause, it can be helpful to wrap a set of round brackets around each individual condition, much like we did with the basic expressions we created earlier on. Now, as you can see here, it's not necessary in this example. The query works and returns the correct results without the round brackets. But just for readability, you might consider doing something like this. So the first logical test 1 on the left-hand side of the AND operator, gets a set of round brackets around it. And then the Oscar wins equals 0, the second logical test, gets its own set of round brackets as well. Now again, this doesn't change the results in this particular example. If I head back to the menu sheet and I run the query again, we'll get the same list of results with the same number of rows returned. The round brackets become more helpful the more complex the conditions you write. For the next example, let's say we want to find all the films that received at least one nomination and that won at least 50% of those nominations. So to do that, our second logical test has to involve an expression, a calculation. We need to divide Oscar wins by the nominations and then check if the result of that is greater than or equal to 0.5 or 50%. So to make that work, I've got Oscar wins. I can divide that by nominations. Now it's debatable whether you would include an extra set of round brackets here to enclose the expression or the calculation. I might be tempted, although it may look a little confusing, to wrap another set of round brackets around just that small part to ensure that the order of operation is in the correct order. So it calculates this division first before comparing it with the value, the constant that we're about to write. So I'm going to say greater than or equal to 0.5. Like many other things, the use of round brackets in situations like this is a matter of preference. There are occasions where round brackets do matter, and we're going to encounter some of those situations shortly. But for this example, this would work perfectly well without any of the round brackets. But just to show you, if I head back to the menu sheet and then run the query, I'll get all the films that won at least half the Oscars that they were nominated for. Again, I haven't shown the percentage or the ratio in another column. We'll do that in another video. Just to demonstrate that it will work without the round brackets, I could happily do the exact same thing without any of these round brackets at all. The order of operation will be performed correctly. So we got 112 rows with that select statement. Let's head back into our menu sheet and run the query again. And once again, we get the same number of results. Sorry, wrong place. Same number of results, returning the exact same rows without the round brackets. Next, I'd like to try to return a list of all of the epic films in my database, and I'm going to define an epic film as one which has received at least 10 Oscar nominations and has a runtime of at least 200 minutes. So let's change the where clause. I'm going to say where the Oscar nominations is greater than or equal to 10, and I can take away this expression at this point all the way up to the 0.5, and I can change that to say runtime greater than or equal to 200. Again, not forgetting to leave a space there at the end of the condition. If you think you might struggle to remember to leave a space here, by the way, there's no harm in including an extra space at the beginning of each clause. The double spaces, even if you include them, will be basically ignored. White space isn't really a cause for concern in your SQL queries. So just in case you were struggling to remember to include the extra space there. Anyway, I haven't used round brackets for this one, so if I head back to the menu sheet and I run my query again, I'll see all the films that match both conditions I've asked for. The nominations is at least 10 and the runtime is at least 200. What if I wanted to relax my criteria slightly? I want to define an epic film as one which has either a runtime of 200 minutes or an Oscar nominations of at least 10. We can do that very simply here, back in the Visual Basic Editor, and I suspect you can predict what we're about to do. We can change the AND keyword to the word OR instead. So if either of these two conditions has been met by any single row, that row will be returned in the result set. So heading back to the menu sheet again, we can click Run Query, and we get quite a few more films now. There are quite a few more films that had at least 10 nominations. If the film has fewer than 10 nominations, then it must have a runtime of 200 or more. Let's expand our where clause to include an extra condition. So I want to keep the same two conditions as we currently have. So that's a runtime of at least 200 minutes or an Oscar nominations of at least 10. But I want to make sure that I only see films if they are in the action genre. So I want to get rid of all of the other genres from the list. You can combine as many different conditions together in the where clause using and or operators pretty much as you like. So after my existing two conditions, nominations greater than or equal to 10 or runtime greater than or equal to 200, I can simply add on an extra condition, this time with the AND keyword, and then I can refer to the genre column, and then I can ask if that is equal to the word action. So don't forget to include your single quotes to wrap up the word action and make sure there's a space there after that as well. Now this isn't going to return the set of results I expect, or at least not the set of results I want. I know what I'm expecting to get from this particular query. So if I head back to the menu sheet, I should be seeing, or what I want to see, are only films in the action genre that I've classed as epic. But that's not anywhere close to what I get. So how is this set of criteria actually working, and why is the number slightly different to the one we had last time, and why isn't it giving us exactly what we want? It's all to do with how these various conditions are grouped together and the order in which they're evaluated. So what we expected to happen, or what I wanted to happen, was that we'd evaluate our initial two conditions first, so if either those two things are true, and the genre is in the action genre. But that's not the way it's worked. The way it's happened is that we've evaluated the nominations category or the nominations criterion separately. So is the nominations value at least 10, or is the film both in the action genre and with a runtime of at least 200? So if I head back to the menu sheet, sorry, beg pardon, the list of results we've just returned, you can see fewer results here. So if the film has not got at least 10 Oscar nominations, it must be both in the action genre with a runtime of at least 200 minutes. Whereas in the previous example, it didn't matter which genre it was in. If it hadn't won at least 10 Oscar nominations, or received at least 10 Oscar nominations, I should say, it doesn't matter which genre it's in, as long as the runtime is at least 200, then it will be returned. So it's basically to do with the order in which things are evaluated. We need to change that order. We want to make sure that these two conditions here are evaluated together before we include the separate criterion for the genre. And the simple way that we do that, as you've probably predicted by now, is to wrap that set of conditions up in a set of round brackets. Optionally, it really doesn't matter, but you could, if you really wanted to, stick an extra set of round brackets around each of the individual conditions. I think that might be a little excessive for this example, but it would also work. The important thing is that these two first conditions joined together with the OR operator gets treated as one logical test, or at least get evaluated together. So if we head back to the menu sheet and we run that query, we do indeed now return all the films that we've considered to be epic, so either with 10 nominations at least, or a runtime of at least 200, and in the action genre. You can see this same basic effect whenever you're combining multiple conditions using combinations of OR and AND. Just to really hammer home the point, let's write another condition. This time I want to see all the films with a runtime of either 90, 120, 150 or 180. So that's quite a long sequence of individual conditions grouped together using the OR operator. So let's just tidy up the condition, the where clause first of all, to say runtime equals 90. Or, and then I'm just going to copy and paste runtime equals 90. This isn't the most efficient way to do this, by the way, but we're going to see a much better way to make this work shortly. So runtime is 90, or runtime is 120, or runtime is 150, or runtime is 180. Okay, so there's the basic criterion. If I head back to the menu sheet and run my query again, I see films with any one of those four individual runtimes. Now I'd like to make it so that we only see films with one of those runtimes if the country is equal to United Kingdom, let's say. So let's head back to the criteria, the where clause in the Visual Basic Editor. I'm going to add the criterion, the first criterion, to the beginning of the where clause this time rather than at the end. And I'm going to ask where country, that's a field, equals, and then in some single quotes, United Kingdom. And the runtime is one of those four values. Now again, we're not going to get the results we want. The default way that these conditions are evaluated, we're going to see films where the country is UK and the runtime is 90, or its runtime is one of these other three values. So we're going to get films from various different countries, providing that the runtimes are one of the other runtimes we've mentioned. Should have perhaps applied a little bit of sorting here to make sure that we see some results in particular orders, but anyway, we can clearly see we're getting lots of films from various different countries using any one of the other runtimes. Once again, to group together these conditions in the appropriate way to make sure that we see any films from the UK with a runtime of one of these four different values, we can wrap a single set of round brackets around all of the OR criteria. And then, having done that, we can switch back to the menu sheet, run the query again, and there we go. Only films made in the United Kingdom with a runtime of one of those four different values. Apparently there aren't any 180 minutes long films made in the UK, so we don't see any results for that particular combination. So I mentioned that there was a slightly easier way to handle situations where you want to test the same field against multiple different values like so. And to do that, we can use another one of our special operators. So we saw the like operator earlier on. Here we're going to use an operator called in, which allows you to check if a value appears in a list of other values. So you can write the column name followed by the in operator and then a comma separated list of values stored in some round brackets. So let's just have a very quick look at how we can do that to replace our multiple runtime conditions. I'm just going to take away the country equals United Kingdom and the open round brackets there. And then I'm just going to take away everything after the first reference to the runtime field. I can then write the word in, and in some round brackets, I can write out that comma separated list. I can include spaces for readability purposes, but you don't need to put spaces after each comma. I'm going to include them just because I think it helps to read what I've written. So if the runtime value for a single row is anywhere in that particular list, then that row of data will be returned. So let's have a look back at the menu sheet. If we run our query again, we're returning all of the films with one of those 4 runtimes, but in a much more succinct and simple way. It doesn't really improve performance in any way. It really is just a way to write your expressions a little bit more neatly, something referred to as syntax sugar or syntactic sugar. It makes writing your code that little bit sweeter. You can then happily tag on to the end of that criterion any further criteria. So let's say we wanted to say and the genre. Beg pardon, I'll use the correct type of brackets there. So genre, let's say equals, should we go for science fiction for a change? Why not? Let's say science fiction. So no need to wrap round brackets around your OR criteria anymore because we don't have any. They're just all contained in one single condition now, one single logical test. So heading back to the menu sheet, running that query again, any films with any one of those 4 runtimes, although it appears as only 120 and 150 minute films in the science fiction genre. We can also use the in operator with text values. So let's say as well as finding films which have one of these 4 runtimes, we wanted to find films in one of 3 different genres. So rather than saying equals science fiction or genre equals fantasy or genre equals martial arts, etc., we can replace those multiple or conditions by saying genre in, and then in a set of round brackets, you must include them in this case, you must include round brackets for your in operator. After the first genre, science fiction, we can create another genre in the list, let's say fantasy. Each genre must be contained in its own set of single quotes, separated by commas, and let's go with martial arts as well, just to try to get a few more results. And then close the round brackets at the end of that in operator. And then heading back to the menu sheet, we can run this query once more, and we'll get a few more results, some martial arts, science fiction and fantasy films with any one of those 4 different runtimes. And of course, as you might expect, you can also use the in operator with date values as well. So let's say we had a specific range of dates we wanted to find films based on their release date. Let's just change our criteria here. I'll say where release date in. I'm just going to take away the genre criteria here as well while I'm here. Let's just get that all the way to the very end and take that away. And then in place of this list of numbers, I'm going to replace each of those with a separate date written in some hash symbols or some pound symbols. So let's go with the same dates we were using earlier on, 2006-10-20. Feel free to use different date formats if you prefer. And then a comma, and then in some more hash marks, I'm going to say 2004-10-01. And then one date that we didn't use in another set of hash marks, 1983-12-09. So if the release date is in, for any individual film, is in that list of 3, then we're going to return a result. Back to the menu sheet, run the query, and there we go, films released on any one of those 3 specific dates. Just as we saw with our like special operator earlier on, we saw we could do like or not like. You can do the same thing with the in special operator. If we wanted to find all the films whose release date was not in that specific list, we can simply add the not operator in front of in. And if we head back to the menu sheet, run the query again, we'll find a list of all of the films except for the 9 which fell or were released on one of those specific dates. So we get 1,191 rows returned. Let's move on and look at another special operator. As we're currently looking at the release date field, let's say we wanted to return a list of films released between the 1st of May 2016 and the 31st of May 2016. We actually have a few choices for how we can do this, and we'll investigate some more options in a later video on working with dates. For now, I want to do it using just simple comparison operators. So I'm going to ask to show all the films where the release date is greater than or equal to, and then I'm just going to take away the round brackets there and just repurpose this date to say 2016-05-01. And then after that, I'll just take away the rest of that criteria. I need to use the AND operator, and then I'm just going to copy and paste what I've just done here. And then check whether the release date is less than or equal to 2016-05-31. So having done that, if I head back to my menu sheet and I click my Run Query button again, that's a list of all the films released in May 2016. Now, it's a little bit long-winded to type that one out. I had to type in the reference to the release date field multiple times. So a slightly easier way, another bit of syntax sugar for you, another bit of sweet code writing. Rather than asking these two separate conditions, we can use a separate operator, a new special operator called between. So the between operator allows you to check if a value falls between two other values without having to write the same column name multiple times. Again, it's no more efficient than what we've just done, it's just a little bit easier to write. So to see how that works, we can say, rather than greater than or equal to, we can say between, and then we can take away the second reference to the release date column, and that will find the exact same set of end results. So if I head back to the menu sheet and run the query, I'll get the same set of 4 films made or released in May 2016. Just as we mentioned earlier on with our dates, if there were films released after midnight on the 31st of May 2016, these would not be included in our set of results. So the between operator is inclusive of the dates we've specified, so it's the same as the previous set of results with greater than or equal to and less than or equal to. But of course, this is currently looking at time 000000 on that date. If we wanted to make sure we got everything up to the very end of that specific date, then don't forget you would want to include your time component as well. So this would be 23:59:59 to make sure that we got everything. Just as with the like and the in special operators, you can also add the not operator before between. So if we wanted to find all the films that were not released between those two dates, we could add not between. Have a look at the results. If we click on the Run Query button on the menu sheet, we'll basically get all the films from the database except for those 4 films that were released between those specified dates. Perhaps unsurprisingly, you can also use the between operator with number columns. So let's change our where clause to refer to the runtime column this time. So runtime, I'm going to ask for films that are between a runtime of 170 and 180. So again, just replacing the slightly longer winded way of doing it where we'd have to say runtime greater than or equal to 170 and runtime less than or equal to 180. So having done that, if I head back to the menu sheet and I hit the Run Query button, I get all the films with a runtime between those two. Notice it's inclusive of the values I've asked for there as well, 170 and 180. And of course I could say not between to reverse that. So I could say not between those two values and I'll get films with any other runtime in the list. Perhaps a little more surprisingly, you can also use the between operator with text columns. But this is just based on the same idea we saw earlier on with our basic comparison operators. You can ask if one bit of text is greater than another bit of text, and that's basically what the between operator is doing. So let's just change our where clause to look for the title column this time. And I'm going to say title between. And I'm going to ask for titles that sit between the letter A and the letter C. I'll also just change my sort order to make things a little easier to see. I'm going to order by title in ascending order. And if you imagined a fully sorted list of film titles and you had to pick everything which fell between the letter A and the letter C inclusive in that list, that would give you the same results. So let's have a quick look. If I run the query, if I head back to my menu sheet and run the query from there, I'll see all the films basically with a title that begins with the letter A, all the way up to and including any film that would be called C. So if there was a film called C in my list, that would be included in the output. But because there are no films with that specific title, we just essentially see all the films beginning with A and B. You can write longer strings of text in there as well. It doesn't really make a huge amount of sense to say this, but if we wanted to find all the films that sit between a rock and a hard place, now I know we don't have films called A Rock and a Hard Place, but alphabetically, if we were to look at that list, those would be the films that we'd return. So let's have a quick look. If we do something a little sillier, we can say between our rock and our hard place. I appreciate that these are in the wrong order, by the way, as well. So a rock falls after a hard place alphabetically, but the between operator is happy to work that part out itself. So heading back to the menu sheet, if I click my run query button, that's the list of films we return. Now, the one type of value we haven't considered so far is the absence of a value. What if a field for a particular row doesn't have a value in it? If I just switch back to the movies workbook and show you a few examples of what I mean by that, I've got both a budget and a box office column, but I couldn't find all the information for these values for every single film. So in this list, if I start at the top of the list and press Control and the down arrow key, it's going to stop immediately above the next blank cell. So I didn't find a budget for that particular film, Magnum Force. And you'll see lots of other examples of that in this list, lots of missing empty cells in there. Now, if you were in Excel, you could be checking for those empty cells in a couple of different ways. You could check if they were equal to 0, or you could check if they were equal to an empty string. But that's not quite the same when we're talking about the provider we're using to connect to an Excel workbook and SQL code and queries. The absence of a value has to be done in a specific way using another special operator, the isNull operator. So let's include the isNull operator in our expression, in our where clause. If we head back to the Visual Basic Editor, I'd like to find all the films whose budget is null. So this is nice and easy to do. You literally say where budget is null. I'll keep the order by title in there, that's absolutely fine. If I then head back to the menu sheet and I run that query, that will return all the films with no value in the budget column. Just wanted to compare that if you did try to ask for films whose budget equals 0, of course you could do that in Excel, but in SQL it doesn't do quite the same thing. There must be a literal exact value of 0 in the row for that film in order for this to work. So if we head back to the menu sheet and run the query again, there aren't any films whose budget equals the value 0. Nor could you ask if it's an empty string. For a couple of reasons, actually, you couldn't ask if this is equal to an empty string. The main reason for this is that the budget column is not a text column, it's a numeric column. So if I try to run this query, by running the query, it gives me a different type of error altogether. It's a data type mismatch error. I can't compare strings against numeric columns. So it must be isNull. Of course, you can combine multiple criteria. If I wanted to find all the films whose budget is null and whose box office is null, then I can happily combine another criterion there to say budget is null and box office is null. And if I head back to the menu sheet and I run that query again, I'll find all the films with no budget and no box office. I could reverse this, or sorry, change this slightly and use the or operator to find films with either a missing budget or a missing box office. Once again, back to the menu sheet. So there, if either of those two values are empty, or either of those two columns are empty, I'll return my set of results. And I can also use the not keyword to reverse what I'm asking for. So let's say I want to find only the films whose budget is not null and whose box office is not null. So make sure I'm basically returning films which have both a budget and a box office column. So combining almost all the things we've done in this video so far, going back to the menu sheet, I can run my query again, and there we go, all the films which have both a budget and a box office value. You can also encounter nulls in both text and date fields. Just to demonstrate that, let's head back to the movies workbook and let's remove the film title for Jurassic Park, and let's remove the release date for Spider-Man. Having done that, if I head back to my Visual Basic editor, if I tried to return any films whose title equals an empty string, again I'm going to fail, this time not with a type mismatch error, but this time simply because there are no empty strings in that column. The missing cells, or the empty cells, are null. So just to demonstrate that, if I head back to my menu sheet and I run my query again, I return no results. Okay, if I change my criteria to say is null, and then run the query again, this time I will return the one single result, which was previously Jurassic Park, but is now null. And the same principle applies for release dates as well. If I head back to my criteria, my where clause, add an or keyword, logical operator, and ask to see where the release date is null. And again, I'm going to return the one single film Spider-Man, which is null, and the one single film Jurassic Park, whose title is null, if I head back to the menu sheet and run my query again. So there we go, there's a reasonably comprehensive look at adding criteria to the where clause of your select statements. In the next part of the series, we're going to look at text criteria in a little bit more detail, including how to make text comparisons case sensitive and how to do more interesting things with the like operator and wildcard characters. So hope you're looking forward to that one. Thanks very much for watching. See you next time.